We perform operations like addition, subtraction, multiplication, division on variables to form expressions. Now let us study some properties of these operations. Suppose you have 3 candies and I give you 2 more candies. How many candies will you have? You'll have 5 candies. But if you have 2 candies and I give you 3 more candies, then how many candies will you have? Again you will have 5 candies. So whether we add 2 to 3 or we add 3 to 2, it does not matter. We get the same answer 5 in each case. And this is true for any 2 numbers. So we say that addition is commutative. And in algebra, since variables are representation for numbers, so we can say x plus y is the same as y plus x. That is, when we are adding variables, order does not matter. And we say that addition is commutative. Now what about subtraction? What is 15 minus 10? It is 5. What is 10 minus 15? It is negative 5. So these two are clearly not equal. So 15 minus 10 is not equal to 10 minus 15. So it does matter whether we are subtracting 10 from 15 or we are subtracting 15 from 10, because order matters here. So we say that commutative property does not hold for subtraction. Similarly, in algebra, x minus y is not equal to y minus x. It is important what we are subtracting from what. So commutative property doesn't hold for subtraction in algebra as well. Suppose you go to a shop A, and buy 4 bags of oranges. Each bag has 3 oranges. So what will be the total number of oranges which you have? Well, total number of oranges will be number of bags into number of oranges in each bag, which is equal to 4, because 4 is the number of bags, into there are 3 oranges per bag. So 4 into 3 gives us 12. Next day, you go to another shop B, and you buy 3 bags of oranges with 4 oranges in each bag. So what is the total number of oranges you have bought? It is number of bags into number of oranges in each bag, which is 3 into 4, which is 12. So we see that 4 into 3 is the same as 3 into 4, which is equal to 12. So in arithmetic, multiplication is commutative. That is, the order in which we multiply does not matter. Similarly, in algebra, when we have 2 variables x and y, whether we write x into y or we write y into x, we get the same answer. And it can be represented as xy or yx. All these are the same things. So we say that multiplication is commutative. Now what about division? 15 divided by 3 gives us 5. 3 divided by 15 gives us 1 by 5. So clearly these two are not equal. So we say that the commutative property does not hold for division in arithmetic. Similarly, in algebra, because variables are representation for numbers, x divided by y is not equal to y divided by x. So commutative property does not hold for division. For which of the following operations the commutative property does not hold? Addition, subtraction, multiplication, none of the above. Well, we have seen that commutative property holds for addition. It does not hold for subtraction. It holds for multiplication. So this is the correct answer. Commutative property does not hold for subtraction. Now suppose you have 3 groups of ball. In the first group, you have 2 balls. In the second group, you have 3 balls. And in the third group, you have 4 balls. And you have to add these 3 groups. One way is by adding these 2 groups first. So you add 2 and 3. You get 5 plus 4. Now you add this to 4 and you get 9. Another way in which you can do is you add these 2 groups first. So you have 3 plus 4, 7. And now you add 2 to it. So you get 9. So we see that we get the same answer in both the cases, which is 9. And this is the associative property. We say that associative property holds for addition. By this we mean that when we have to add 3 or more terms, which 2 terms do we add first does not matter. Or we can say the way we group terms does not matter. Here we have added 2 and 3 first. Here we have added 3 and 4 first. But we always get the same answer. Similar is the case in algebra. X plus y plus z. So whether we add x plus y first and then add z to it, or whether we add y and z first and then add x to it, it does not make a difference. And we can say that associative property holds for addition. Coming to subtraction, what does it give us? X minus y minus z. So when we open the bracket, we get x minus y plus z. And here we get x minus y minus z. So we have a plus z here and we have a negative z here. So these are 2 different things. So we see that these 2 are not equal. So we can say that associative property does not hold for subtraction. Coming to multiplication, 4 into 2 gives us 8. 8 into 5, which is 40. Now, we multiply 2 and 5 first, which gives us 10. This is again 40. So, which 2 terms are we multiplying first is not making any difference to the answer. It remains 40. So, we say that associative property holds for multiplication. Similarly, in algebra also, associative property holds for multiplication. So, associative property, it holds for addition, it does not hold for subtraction, and it holds for multiplication. Now, are these 2 equal? Let us see. This is 4 into 3 plus 2 is 5, which is 20. And this is 4 into 3, 12, plus 4 into 2, 8. 12 plus 8 is 20. So yes, these 2 are equal. So what is happening here? Here 4 is being distributed over 3 and 2. 4 is being multiplied with this expression. So 4 is being it is equivalent to multiplying 4 with 3 and multiplying 4 with 2 and then adding it. Now let us consider this. 4 plus 3 into 2, 6. 4 plus 6 is 10. And this side is 4 plus 3, 7 into 4 plus 2, 6. This is 42. So these 2 are clearly not equal. So when we have 4 plus something, it does not get distributed over multiplication. So we can say that multiplication distributes over addition. Multiplication distributes over addition, But addition does not distribute over multiplication. So addition does not distribute over multiplication. And this is how the distributive property holds. Similarly, in algebra, multiplication distributes over addition, but addition does not distribute over multiplication, and this is how the distributive property holds.